Very good evening and welcome back to another session of data science in association with 360DigiTMG, and we are in telecom analytics. And yesterday we have understood the business problem, and also we have understood that the constraints and limitations and aim are very important for us to record. So in this, we need to do minimization or maximization words, which will be very good. And whatever you are recording, all the recordings should fix in project charter. And the project charter is a high level document where you are able to perform all the, you are trying to fill in all the details. What are the process, challenges, timelines, all the error logs, everything is there in the project charter. So assume that now you have collected the data, and the data, what you have collected, the data you have collected, and to go and do the model building, we want to understand the data types. So we should understand the data types, we should understand the different EDA part, so that we will go and do model building here. So first of all, you should this is mind map where we can understand things. So this is our crisp MLQ methodology where we have discussed yesterday these 6 steps, and these 6 steps will complete the entire project related to telecom. So yesterday we have understood the project charter, business problem, and all that. Now today we are going to understand the data types. So data types, with respect to stats, with respect to data, they are broadly classified into discrete and continuous. Okay, they are divided into discrete and continuous. Continuous data is a data where you will measure anything up to a desired accuracy, especially when you are paying the amount. Right? You will say it is a monthly charge, or you say it is a weekly charge, or you are paying 58 rupees for 2 GB of data plan. All this, now 58 can be written as 58.50 pies. Right? You can also have 5656 like this. Desired accuracy, you can measure it. Right? The bandwidth, the frequency, whatever we have with the data, which is very continuous here, and the continuous data, it is going to, we are going to measure it to a desired level. It is going to measure to a desired level, that is continuous data. But when it comes to discrete data, you are only having countable data where you count. There is no question of decimals coming into picture. And these are further classified into count and categorical. This is how many customers are using, number of locations, or number of customers are using my network, right? Number of locations where you are facing some bandwidth issue, number of complaints raised, number of tickets closed. All these would come under count data. But when it comes to categorical data, it is a category, and you cannot perform any math operations on top of that. You cannot perform any math operations on top of that, and those math operations you cannot do. So it is a category. It is like yes and no. Complaint raised, not raised. Customer churned, not churned. Paid the bill with the complaint is registered via internet, no internet. The bill is paid through credit card or through GPay or through your cache. So this can be binary category or it can be multiple categories also. Right? It can be multiple categories also. So what is that we are trying to understand? Binary or multiple categories means no math operation can be performed. So we are going to deal with this data only. We are going to only deal with this data. Right? So this data is nothing but you are having combinational data collected and this data is given by the client. Right? Whether they are senior citizens or not. Yes or no scenario, you call it as a binary. Multiple categories is 3 categories, which is nothing but greater than 2. Right? Whatever data you have been collected here, that data is nothing but you call it as population data. Whatever data you have collected, it is called as population data. This population data is represented with capital N. All the data what you have is population data. And this population data, we don't have enough resources to work with this population data. So what we will do is we will close our eyes and we pick a sample data. So this is denoted by capital N. I close my eyes and randomly pull few data points into this, few customers data into the sample like this. This is my entire population data. This data is represented with a capital N, out of which I pick few people in the sample. If you observe, we have seen recently an this Airtel's ad in television. They are aiming for 0 complaints registration. So they are just they were scrolling down in different locations. How are the complaints getting reduced? How are the tickets are getting closed? Right? So that's nothing but they are randomly going to one or the other location. They're not going to all the states in our country. They are not picking each and every person and not picking each and every person who are using Airtel network. What did they do? They closed their eyes and they just on our country map, they have picked a few locations here, randomly went to that particular location and they were asking the complaint number, like how many complaints are getting registered on a daily basis. Right? So those dots, what I have drawn here, that is your sample. But the question here is how you are going to pick up those locations just like that. For that, you from such a big population, you have to pull in very small sample. So how is that possible? What people say here is that there is a concept called as inferential statistics. Okay, there is a concept called as inferential statistics. This inferential statistics, it is going to work with sample, but it is going to register inferential statistics. Whatever you are getting results, it is going to generalize it and it is going to talk on population. It is going to say that if entire people, it became a 0 complaint registration day, it will say that all the people in our country, they are having no complaints with our network. But they did not take each and every person who are using Airtel network. So this is your population. This is your sample. And this is your technique, what you are using. I have used a technique, which is a default technique, which is called as simple random sampling. It is called as simple random sampling. So it's very difficult for us to choose a sample of small n. So what we will do is we apply a condition on population, that condition should be unique, and you say that sampling frame. So what could be that unique condition? The unique condition is that the person might be using Airtel network. Those who are using Airtel network for a period of 1 year, only those people should come into this particular funnel. All entire country people who are using Airtel are your population. Airtel users are your population. But out of which who are using that Airtel network from 1 year, if you apply, half of them will get cut shorted there. From that, you pick up the people, and those people will be your sample. So applying a unique condition on population is called as a sampling frame, because none of the organizations none of the network would work with the population data. They always work with the sample data. Whatever you work is sample, because people should have so many resources to work with the population data. And this is very, very huge data, and we don't have enough resources to work with this. So this is called as, this is structure, if you see, it is like a funnel shape. Hence the name, it is a sampling funnel. It is called as sampling funnel. So the point here is, using this, now you have picked up the sample and you have got the data types broadly classified into count, categorical, and continuous. These are the data types what we have. In this now, if you are getting a data nicely in a beautiful format of row and columns, right, it is called as structured data. But if you are performing analysis on the complaints registered via email through internet, it will be text data. You have explanatory marks, you have smileys, you have question marks, inverted commas, like this. These are your unstructured data. Airtel stores the data like this. Airtel registers the complaints like this, but it is still a text data. So it is a unstructured data where it has symbols, smileys, apostrophes, stop words, prepositions, so much is there, which is a unstructured format of data. So we will deal with this data, we have to deal with this data, we have to deal with many types of data. So when we have collected this, so we have understood that count, categorical, and what is continuous. These are our data types, broadly classified into these two. Then once you collected this data, you should start doing descriptive statistics. You are doing descriptive statistics. What is this descriptive statistics? It is the first stage, and you are exploring the data, what happened in the past. Okay, what happened in the past. So the data is given to you like this. This is the data, it is given to you. Right? It's all raw data, and it is a sample data what you have here. So if you observe here, it is a combination of categorical and numeric. You have various columns, whether a person is a male or a female, it's a category. He's a senior citizen or not senior citizen, it's a category, right? They are using, is it a partner or not? Are there any dependents or not? What is the tenure of using? Do they use even phone service? Right? Multiple lines are there. Do they avail even internet service? Right? What about the online security payment they are doing? Are they maintaining this backup? What about the device protection? Right? Tech support. Are they using streaming television? Streaming movies? Are they doing this contract for 1 year, 2 year, 3 year? Is it a paperless billing? What is the payment method? What is the monthly charges? What is the total charge? A customer churned or not churned. So leave about this part. Reason could be anything. He may be there with us, he may not be there with us, he might like our service, he might not like our service. So looking at these data now, if you see the tenure, you can also write it as 1.1 month, 2.1, 34.1. It is a continuous data. And you can measure it to a desired accuracy. Right? But the other columns, I cannot do anything. And again, you have a continuous column which is a monthly charges. For this particular guy, monthly and total charges are same. For him, 56 and it became 1889. According to the charges, according to his interest, the bill is improved, like it is from 56 to 2000 nearly. Right? So this is how a data looks like. Now, if I have to go to any continuous column now, if I take this column, can you say that how much is a monthly charge happening for this particular network in a month, if this is a data related to one particular location? Different customers' IDs are there here. It's a combination of male and female. The question is, what would be, how can you look at this data set and tell me the amount, the bill people are paying to this network? So you will go sit down and look all these 2000 data points and check how about this average here. You cannot calculate like that. Right? So for that purpose, what you do is you calculate something called as average. You calculate something called as average. So average is nothing but you are taking the data, you are summing up and you are calling it as average. Average is the first thing you would like to do as a part of your descriptive stats. Okay. What happened means what happened in the past. What is the average number of charges which are being paid by the people who are using Airtel network or Jio network or something else? It is nothing but you are doing sum by total. So you're adding up all the people's data, all the people's monthly charges by total, which is giving me the average. This is the first thing any particular person should start and should, that's why, yeah, this is called as the first business moment decision. This is the first fact value you are getting from the data. But if you observe this particular data set, you are able to do something called as outliers might be there in your data. If you observe this, see here, 54 is an extreme number, 45 is another extreme number, 2000. So not all the people are paying same amount, right? There could be any reason that they are paying high amount. That high amount is paid by them every month, or is there an unusuality that they are paying only for this month, right? So if all the people are paying certain amount like this, all are going in a sequence of till 4,000, it is a normal pay. Generally, every customer pays around 4,000 rupees. But suddenly, if it is increased and it is moving like 6,000, for few people are paying 8,000, 7,000 like this, it is out of scope there. Such data points are called as outliers in your data. And outliers are calculated for continuous data. So what is this? These outliers are nothing but extreme values, exceptional values in your data. These are the exceptional values in your data. So which have to be rectified. So if at all your data, we'll see how we can check that. If at all the data is holding some kind of what you call it as outliers, you just won't go for mean, you go for median, which is nothing but your middlemost value. of your data. If you're having categorical data like this, phone service, yes or no, he's a senior citizen or not, he churned or not churned, how many dependents are there, he had a dependent or not, yes or no, right? He paid through credit card or through online, offline or cash or online, or it's a bank transfer. All these are categorical. So you apply mode, which is the most repeated value in your data set for one particular column. Okay, you're doing it for one particular column. So what is that you are doing here is, when you try to check this, when you try to do this, these are the first decisions what you take as a part of descriptive statistics. There is one more which is called as variance. Variance is nothing but it is the variation you observe in the data. Like what is the minimum value? What is the minimum monthly charge they are paying? What is the maximum monthly charge they are paying? Is there any variation in the data? Right? Are they maintaining any consistency, or is there any inconsistency in the data? That can be measured, and that is your second business moment decisions. Okay, so what you are going to do here, this one is going to help you to understand how is the variation, what is the minimum value, what is the maximum value. So people also take into consideration something called as standard deviation, and they do it as square root of variance. They say that it is square root of variance. So this is nothing but for calculation purpose we are taking, because here variation formula is designed in such a way that the units are getting squared. To counter that, we are not taking variance, we are taking standard deviation. Okay, and the next thing is, we have the third business moment decision, which is skewness. This is exclusively designed for only continuous data, and this talks about the how you have outliers. Do you have any outliers? Like how many outliers are there? Is there any skewness in your data? Generally, people have designed as a part of data science that everything around us is normal. So they took this as normal. But in reality, this is a graph you are going to get. This is called as a normal graph. But if at all you are having like this, people say that it is something. What you do is, you have to check with the outliers. So you have more outliers in the data is not normal. To capture that, we are going for skewness. Okay, if you do a plot like this plot is called as a histogram plot, which will help you to measure the third and fourth business moment decisions. Okay, third and business decision. So here they do a plot which is called as a histogram, and this histogram is helping you to find out whether your data is normal or not, because it is a mandatory thing to check, right? It is a mandatory thing to check whether your data are normal or not. So this is a histogram. If your data goes like this, or if your data goes like this, you say that your data is not normal. So you cannot build any algorithm, right? You cannot do any model building here. So what will happen here? The case what you're talking here is, the check what you're doing here is whether your data are normal or not. That can be quantified with the skewness. We check skewness. There is one more which is called as peak. How is your peak? Is it a sharp peak or it is a normal wider peak? This is sharp peak or it's a normal wider peak. And this is nothing but kurtosis. This is nothing but, you call it as kurtosis. So kurtosis is fourth business moment decision, and this is third business moment decision. Okay, to do all this, to visualize this, to process this EDA, we need to take Python, right? Where we are using Google Colab to run all the machine learning algorithms to do EDA. So what is that we are doing here? This is a platform. How do you open Google Colab? It's just that you go to Google and write Google Colab. It will ask you to log in through your Gmail account, like whatever account you have. This is how it looks like. And you can open a notebook like this. So the environment is similar and all the environments are similar, right? All the Python language, Python commands what you're writing are also similar. But the way the environment, like interior development environment, what you're doing, some minor changes are there, like how do you run the code, right? Those things, interfaces are different. So this Python is helping us to understand, do EDA without any, like what issues we face with Excel. Because Excel cannot handle very, very large data here. So what we will do, you should understand Python first. So Python is an open source language. It's a tool instead of language. And this is coming up with something called as 26,000 packages. And the person who was behind this is Udo van Rossum. And he was watching Monty Python Flying Circus show, which made him to give a name called as Python. So all that we need to do is, this is a community which is working behind the scenes. These communities are writing predefined functions. These are doing predefined functions. These are pre-written and they're kept ready to calculate mean, to calculate median, to calculate skewness. All these things are already ready, rewritten. You need not pre-written, you need not rewrite them. So where are these stored? These are stored in packages. So like that, community is working every day. They are starting one or the other package. Every day we are taking one or the other person is introducing one package, is doing modifications to the package. So this is where we are interested in this Python, because of the how you write your codes. It's the basic English what we use here. We use basic English here to write the codes. So out of all these 26,000 packages, we are not using all. We are only using 5 to 6 packages on daily basis. Other packages would come and go, not on daily basis, but there are few packages which we do every time. Okay, so when we are running this Google Colab, right, you can open a new notebook here. Okay, you can do runtime. You can run all the cells at a time. You can run one after the other. You can run the current selection line. Okay, you can insert a new code cell like this. You can insert a new text cell. You can select a header cell. Okay, you can select the header cell. You can delete them also if you are not required. Okay. So the good thing is that you can write your text here only. You're inserting your text cell, so you can introduce from here also. So to perform like that, you write it here only. Finish. You can do this. So what is that we are interested in? We are interested in understanding the data, doing descriptive statistics. So for that, we want 4 to 5 packages, and we are going to use daily these packages. And which is SQL also. So what are we doing here? It is nothing but NumPy, Pandas, Matplotlib, sklearn. These are the packages, and these packages are having functions which are returned. These are all are installed. They are readily available in Google Colab. You need not install anything. So what is that you do? Only thing is you use it. For using that, you use import. For using that, you use import that particular package name. And if you want, you can give a nickname to those packages, which is NumPy. You can give a nickname to it. It is Pandas. Right? For matplotlib.pyplot, you can give a nickname as PLT. How do you use it? You should write import pandas as NP, import pandas as PD, import matplotlib as PLT. Whatever stats you want to perform, you can perform this. So how are you using these packages? NumPy package is a package which is used to perform all arithmetic operations. You're doing all arithmetic operations. Pandas is something you're using for data manipulations. Matplotlib is something which is used for plots. And finally, you have few other like SciPy, Seaborn, which are similar to them, advanced. So NumPy advanced is SciPy, Matplotlib advanced is Seaborn. All our packages all have the functions. If you want to use these packages, you have to go and use a keyword called import. You have to use a keyword import. So you import NumPy as NP, you import Pandas as PD, you import all the packages and you did not install them. They are available. So Pandas is something which is used for data manipulation. So you are using pd.read_csv. This is a function. So to use any function, or this is NumPy, this is Pandas, this is Matplotlib. To do any task, to perform any task, if at all I want to pull the data from my system to this Google Colab, what will happen? I should say Pandas is having a function which is called as read_csv. Right? So every time dot. So if you give a nickname to Pandas, you should say pd.read_csv and you paste the path. Where is that particular data set? So even before that, I should do that. I have to pull this. Okay, using this button, select that, click OK. You will get this data into your Colab environment. You're giving it to the Colab environment. Then what will I do? I'll just click on this. I'll copy the path. Read_csv is a function. I paste it here. Like this. I just paste this. If I run this now, And if I just show you what is this now, data, how the data looks, so this is the data. Whether it is services to DSL or it is fiber optic, if data is available or not, right? Support, contract, paperless. So many columns are there which are categorical, which are discrete as well, and which have time also into picture. So it is a data set, very huge data set, 7,043 right, data points I have with 21 columns I have. So these are nothing but my dimensions. These are nothing but my observations. These are nothing but my dimensions. Okay. So it's very good that you need not give it from your end, right? Python itself is very clever. It understands the data types. How will you do? You should use a dot command here to get the D types. It's nothing but data dot D types. If you run this, it is giving me that there are few integers, numbers here, and most of them are object. Object means it is a categorical data. Object means it is categorical data. Then I should do information. It will tell you, do you have any null values in the data? Data collected, given by the client, it might have some null values, and these null values are the data which is not available. So for all the columns, you can check the null values. You see that there is no null value. Info is a function. So data set name dot info. Right now, there's one function where I need to perform EDA using one particular function. That is nothing but describe function. So describe function is giving me information about the data, all the columns which are numeric, integer, float. Those three columns, it is giving me the mean, which I have explained you as a first business moment decision. It has given me the standard deviation, which is square root of variance. Where did the data start? Where did the maximum value end? Right? And are there any outliers or data? And this is your median value given. Median value is given for this. So if I talk about this, I would like to show if plt dot hist function, I have data, and in that I have a column called as monthly charges. So MCAP, so this is case sensitive, you should do accordingly. Data dot monthly charges. If I run this, I got a plot. So it's just, if you connect all the corners and you try to draw a plot, it is something like this. So what is this? This is not a normal. I was expecting something which is a continuous data and I want it to be like this. But something came like this weird pattern. How much is the weirdness? For that, I have to go and check, quantify it with a number, which is a skewness. So see here, it is saying that it is a negative skew. If I do same thing on tenure column, if I do this on tenure column, T small, what am I doing? I'm taking a plot which is available in a histogram, right? See here. It's a kind, people are thinking that it's a kind of like something like this. It's not even like this, it is like this, joining all the hands. So I'm a bit confused whether the data is continuous or not. So what will I do? I will check the skewness. So this skewness is positive skewness. This is negative skewness. Similarly, you can perform cut on the entire data, whether you are having a sharp peak or whether you are having a wider peak. If you have a sharp peak, you call it as positive kurtosis. If the data is like this, see here, we have seen like this data only. That's why you got it as a negative kurtosis. Okay, this is your negative kurtosis. Well, that's what we got. We could see in a histogram. Just because we are looking at the shapes and we are pulling out some insights, you call them as shape statistics. You call it as shape statistics. Right? You can make this very, very pretty good. This is how it looks on total data set also. I can give the figure size and do the plot. This is how the plot looks like. We need not perform on senior citizen column because it is integer. Although it is integer, it is categorical only. Okay. If you observe here, most of the data is categorical here. Machine cannot understand such data. Machine cannot understand such data. So it will ask us to convert it into numeric format. Then only I can understand. So for that, you should do a pre-processing. This is something you call it as a pre-processing, which is required even before you build your model. It's a pre-processing what you do even before you build your model. That is a data mining concepts even before you do that. So what you are going to do, this is called as label encoding, making your categorical data into numeric format. How it is going to do? For an instance, now if I say that you have a column which is a phone service, yes or no, they do use a phone service, like they have a landline phone or not. They're checking that also, because people, how well, if they have TV, if they have mobile phone, they have the network, they have what you call as internet, right? Everything is related to only Airtel. The churn of that particular customer, the probability will be very, very less, because he got used to it. He's very, very loyal to Airtel. So don't take chance of moving to another network because he is well satisfied. But sometimes hurdles come, network outage happens, network bandwidth is not reached, and because of that reasons, maybe they would have registered a complaint, and if it's not resolved many times, then they get irritated. So how it is going to work here? Now, if I take internet service, any column you take here, right? See here, you have various columns here. How are the payment method happening? Electronic check, mail check, bank transfer, credit card automatic. So these are various categories. If I have to pass it to the data mining, machine learning algorithm, machine don't understand. What we should do? We will do something called as label encoding. There are two techniques, that is one-hot encoding and label encoding. Okay, but which one is better? It all depends upon the type of data you collect. How it is going to work? It is taking the first letter set of every particular word. Okay, every word it will take. In the alphabetical order, it gives numbers. And one more thing is that Python, our Rossum felt that 0 should have some value. That 0 should not be always 0. Like you're a useless guy, 0 should not be a useless number. Right? People say, right, you're a useless guy, you don't have any value, all that. So 0 also feels always the same, right? So Rossum has given some identity to 0 in Python. Every index numbers, if you see, it starts from 0. Your collection of data starts from 0. Python will skip one data point if you start from 1. This is totally gone. So here 0 is something it is going to start. So in this manner, now when you're performing label encoding, right, when you're doing this creation, it will take the first letters. Okay, it will take the first letters, and these letters are ordered by the way they come in the alphabets. Now B comes first, then C comes, then this, then this. This is called as performing label encoding. Performing label encoding. Right? So based on the order of your alphabets coming up, A to Z, you are going to do transform it. So that is available in our sklearn package. So you have such a big sklearn. In that you have sub modules like this. You break down, right? You have so many sections like this. You have sections like this. Every section is used for some or the other purpose. So sklearn, this section, it is used for pre-processing. Okay, this section is used for pre-processing. In pre-processing, you have one element, that is one function which is called as label encoder. Okay, so I'm going to do that. Okay, I am initializing it. I just pulled it. Now I'm saying that go to data, go to this partner column, transform it. Go to dependents column. I can do it on a single go also, but for explanation purpose, I have written phone service also, multiple lines, this also. Like that, how many columns you have? All those columns we will convert. Where are we doing it? In the same column. Okay, all are gone. Now we will go and run this data. See here, everything got changed. 0, 1, 2, 0, 1, 2, 0, 1, 2. We did not do on payment method. We did not do on contract. Hence, that's why it is just giving you ones and zeros. Numbers as is. Others are numerical data. So if everything is in a single format, now customer ID you can drop. It's not required. It's just like an ID which is given for you to understand. And if at all you want to check any missing values are there in your data, right? And we'll come back to that. You will just do is any NA values are there or not. Are there any NA values in your data? It will throw you, if data is missing, it will throw you true. Otherwise, it will throw you false. So if you observe here, if you want to, you cannot check like this, right? It's very difficult for us to check. We'll do sum. This will give me that there are any null values or not. See, no null values at all. And if I have to check any duplicated records are there, because the data is merged from different sources, different sources. If at all I have to check, are there any duplicates, repetition of the same, right? 0. There are no duplicates. Sum of the duplicates is 0. So are you having any outliers in your data? So normal visualizations you can do it in matplotlib package, but if at all you want very high, rich, colorful visualizations, you want to do for sns.boxplot. If you run this, I've passed all the data, and this is where you can see few outliers. This is how it looks like. So it's just like your describe output. It is telling you that this is a box region. This is your median. If any outliers are there, it will show you like this. Okay? It will show you the outliers like that. Okay. If you want to do like that, you should just say data dot if I'm not wrong, charges. See here, this is how the box plot is. You have tenure column. Is there any outlier in that particular column? So box plot will give you tenure is also not having any outlier. Now, what are the other columns where we can perform here? We have tenure and monthly charges. Those are only two columns where we can perform this one. So we have total charges. Let us give a try on total charges. T caps, C caps. It is a case sensitive, right? So we have to do that. So data dot, delete this. T caps. So after I understand and I do this treatment, I'm wrong. Charges, C caps. It's case sensitive, no? There's something wrong. Correct, right? Total. Not sure why. Okay. Don't know what's the point here. So what was the earlier one? You got data equal to data. Right? Leave this. You want box plot LOP. Okay. But this is the total charges. See here. Okay, we have checked the missing values. We have to do now outlier treatment. So how this box plot is giving you the output? It's nothing but it will try to accommodate all the data here. And if this is called as your Q1, this is called as your Q2 and Q3. This Q1 is calculated with 25th percentile value. Okay, this Q3 is calculated at 75th percentile value. And this is your median. Okay, if this is called as your IQR region. Okay, if any value, now they give a value of Q1 minus 1.5 into IQR, Q3 plus 1.5 into IQR. If any value less than this and greater than this, they will be plotted as circles in your data plot. That is called as outliers. So you can do a treatment of these outliers, right? By finding out all these three values, IQR, Q1, Q3 and all that, right? Or you can directly do a treatment called as Winsorizer. So Winsorizer is a technique where you perform treatment on the data. Okay, you perform treatment on your data so that all the outliers are compressed. So whatever outliers are there on the lower side, whatever outliers are there on the upper side, you forcibly pull them to 5th percentile and 95th percentile. You map all these values to this value, whatever percentile you are getting. You map all this value to this percentile. So it is nothing but forcibly mapping outliers to those two values. So that is available in feature engine outliers import Winsorizer. What is the criteria I said? IQR, tails on both sides. Whatever formula I have written, that is a Q1 minus 1.5 into IQR. So fold is this formula. On what variable? I'm doing it on monthly charges. Okay, I give this. This is my initialization and I ask it to apply on my monthly charges column. Okay, monthly charges column. So this is going to give me the treatment of any outliers you have, that will go and get mapped with these two values. So how do you calculate that percentiles values? You calculate using the quantile. What is IQR? This total value is your Q3. This total value is your Q1, which is your IQR. How are you calculating your lower limit? You are calculating using Q1 minus 1.52 IQR, right? This is your Q3 plus 1.52 IQR. Any value which is less than this, any value which is greater than this is your outlier. If at all your outlier, you come and do this. And if there are any outliers, it makes like this. We don't have any outliers in this scenario, but it makes like this. So taking understanding of the data when it is completed here, now tomorrow we should understand and go for data mining concepts. How do you take this understanding to data mining? How do you build a machine learning algorithm is our next concept. So thank you all for joining in. Thank you so much.